It is now entirely possible for Google's generative AI to explicitly recommend a domain that its own classic search engine denies exists. Look at this AI overview text. It evaluates our test subject, a cycling and travel blog, and explicitly labels it a highly useful resource, pulling in the author's local guide credentials. But when we run a direct site operator query in classic Google search for that exact same domain, the index returns 0 results. Even searching for the exact name of the blog only surfaces third-party links from Facebook and Komoot. The root domain itself is missing. This presents a distinct engineering problem. How do you troubleshoot a domain exclusion when the most advanced AI system already identifies the site as a high-value expert source? Our test subject is AleLublin, a well-established local history and travel blog hosted on Google's own legacy infrastructure, Blogger. Throughout 2025, it generated steady organic traffic and was actively monetized through Google AdSense without any technical warnings. Then, in early 2026, the indexed page count suddenly dropped to 0. To isolate the cause, we have to discard standard SEO assumptions and use command line data to test this as a systemic architectural failure. Understanding this decoupling between AI and classic search means mapping a hidden disconnect in the ingestion pipeline. We start with the most basic variables. Is the server dead, or has the domain been globally penalized? Direct external traffic from social media still loads the site perfectly in standard web browsers. We also have a control group. Microsoft Bing successfully crawls and indexes the entire domain. If the server is healthy, the next hypothesis is a configuration error specifically blocking Google's crawler. We can bypass the browser and talk directly to the server by spoofing the Googlebot user agent in the terminal. The output returns a clean HTTP 200 OK. We confirm this data against Google's internal settings. The domain ownership is verified, and the robots.txt file is perfectly valid. Because the site is globally accessible and returns clean headers to Googlebot, the exclusion is not happening at the edge of the network. It is happening deeper inside Google's internal pipeline. To test the internal fetching architecture directly, we move into Google Search Console. When we execute a live URL test, the system immediately returns green checkmarks, confirming Google can access the URL. Google's own diagnostic explicitly states the page is technically eligible for indexation right now. Yet the historical page indexing report contradicts this flawless live test by persistently flagging dozens of URLs under a redirect error. Google's systems attempted a secondary validation of this redirect error, but the validation failed, even as the live URL remained perfectly healthy. This exposes what we call the live test fallacy. Confirming a page is technically fetchable does not guarantee algorithmic admission into the historical search index. We need to understand why Google's historical index flags a redirect error on a page that currently returns a 200 OK. The answer lies in a specific architectural quirk of the legacy Blogger infrastructure, mobile redirect loops. When a crawler requests the base desktop URL, it enters the standard entry point. If the server detects the Googlebot smartphone user agent, it intercepts the request. It forces a temporary 302 redirect, appending a specific mobile parameter to the URL. The request successfully terminates in a 200 OK, with a canonical tag pointing back to the original desktop URL. This multi-hop chain is valid web architecture, but executing it requires active computational resources from the crawler. If a crawler lacks the computational energy to follow this specific redirect chain to its conclusion, it abandons the attempt and permanently brands the URL with a redirect error. Why would the Googlebot infrastructure lack the energy to follow a basic platform redirect? The behavior is controlled by an underlying algorithmic constraint, the crawl budget. Crawl budget is a dynamic allocation of compute power, and Google appears to heavily limit these resources on certain legacy platforms. This chart visualizes the final forensic proof. It tracks crawl requests over 90 days, flatlining at just 8 requests. This is a severe state of crawler starvation. Because this allocation is systemic, manual pings and live UI tests cannot restore the missing budget required to process the site's backlog. Technical perfection and a clean code base are useless if the algorithmic resource allocation has been revoked, which brings us back to our opening paradox. If the crawler is starved and the index is empty, how does the AI overview know so much about the site? The classic search pipeline is entirely dependent on the physical, budgeted act of crawling the host server. The AI pipeline synthesizes historical knowledge graph data and offsite signals, bypassing the crawler's constraints entirely. AI systems assess experience, expertise, authoritativeness, and trustworthiness by analyzing the surrounding digital ecosystem without ever needing a live host crawl. The strategic takeaway is clear. Stop exhausting resources fighting black box crawl algorithms and start building out offsite ecosystems like video and social that feed AI models directly. In the decoupled era of generative AI, having a healthy server isn't enough. You need an entity footprint large enough to survive a classic crawler blackout.